We continue our discussion of division of polynomials by talking about long division today, or long division. So we want to use the technique of long division to divide our polynomials. And I want to begin by going over the steps of long division with real numbers that we know. So let's start by dividing 31 into 5392. Think about the steps that we go through when we actually divide these numbers, and we learned how to do this a long time ago. The first thing I think about is 31 is a double-digit number, so I'm really looking at these two numbers right here to find out whether or not 31 will divide into 53. I know it won't divide into 5 because it's too big, so I had to move one step to the right, and I'm going to say, how many times does 31 divide into 53? Well, in this case it's 1. 1 times 31 is 31. And I put that subtraction sign up there too quickly, but that's exactly how fast we do this. When the next step in my division is to subtract my term from the 53, and when I subtract I get 22, and I'm going to bring my 9 down so I can say, now how many times does 31 divide into 229? So I'm going to say, well, 7. 7 times 31 is 217. Remember, with long division we subtract. So when I subtract these two numbers I get 12, but I have to bring my 2 down. So now I say, how many times does 31 divide into 122? That's going to be 3. 3 times 31 is 93. Subtract, and I'm left with 29. In this case, we get a remainder of 29. And we have to remember that when I write a remainder as a fraction, I take the remainder and I write it over this term, 31, which we call the divisor. So I take the remainder and I write it over the divisor, and my answer is 173 and 29/31. So let me back up and say that this 31 is called the divisor, and the number under the house, this number we're dividing into, this is called the dividend. And we might need to know those terms as we progress further. So now let's practice doing long division with an actual problem. Here we have the polynomial x squared plus 9x plus 20. I'm dividing it by x plus 5. Notice that I have to use long division in this case because my denominator is not a monomial. There are actually two terms. This is a binomial, so I have to use something other than the technique used in the last lecture. So we're going to write x plus 5 on the outside. The denominator is written on the outside. The numerator is written on the inside. X squared plus 9x plus 20. And when I look and try to think, I'm going to try to see how many times x, in this case x, is going to divide into x squared. And that is, I need to say, how can I turn x into x squared? Well, I need to multiply by x. So x times x gives me x squared. And I have another term here to multiply by. X times 5 times a plus 5 gives me plus 5x. Now what did we do just a minute ago when we did regular division? But we subtracted at this point. So I need to come through and I'm going to subtract this term and I'm going to subtract that term. And I'm left with 4x plus 20 because I needed to bring my 20 down. Now I look at this x and I say, what do I need to multiply this x by to turn it into 4x? And that's just a 4. So 4 times 4 times x is 4x, and 4 times 5 is 20. Remember, we have to do subtraction here, so I'm going to subtract both of these terms, and when I do subtract, I get a remainder of 0. So the answer to this division problem is actually x plus 4. In order to check my answer, I could very easily take this term, which is the quotient, multiply it by the outside term, which is the dividend, to check that I'm going to get this term, which is this is the divisor, multiply the top by the outside to see if you get the inside. So now let's practice that again. Here we have a polynomial being divided by a binomial. We can't use our monomial division like we did a minute ago with the fractions. So instead we need to rewrite negative 5x minus 2 on the outside with negative 20x cubed plus 17x squared plus 15x plus 13. And that's going to be underneath the house. So I start out by always looking at this outside term of my divisor, the negative 5x in this case, and I think, how can I turn negative 5x into negative 20x cubed? Well, I need to multiply negative 5 by a 4, and then I need to multiply the x by an x squared to get x cubed. So I put this in its second position over here. It's almost a place value. Because I have 2 terms on the outside here, I need to start 2 terms in on the inside. That's where I know where to put my first number. So I multiply 4x squared times negative 5x to give me negative 20x cubed. And 4x squared times a negative 2 gives me a minus 8x squared. The trick here, remember, I have to actually subtract this whole polynomial. What happens when I subtract that? But I actually will go in, and I'm going to erase these for a minute. I'm going to go in, and I'm really just changing my signs. So I can change this sign and change this sign. So now it's negative 20x cubed plus 20x cubed gives me 0, and 17x squared plus 8x squared is 25x squared. Bring my 15x down. I'm going to stop here and I'm going to back up just so that we understand why I did that step. Let's take this 17 and write it over here to the side. What this said is I had 17 and I was subtracting an original negative 8. When I do that, I have to change, which really changed this into an addition, and that's how I got 25x squared. Okay, so let's go back. I'm looking at this negative 5x, and I want to see how I can turn negative 5x into positive 25x squared. Well, I'm going to multiply it by a negative 5x, because negative 5 times negative 5 is a positive 25, and x times x is x squared. And then I have a negative 5x times a negative 2, so I get a positive 10x. But I have to subtract these two terms, so I'm going to subtract. When I add straight down, I end up with 5x, and I'm going to bring this 13 all the way down, 5x plus 13. So now the last part of my division problem, almost done from here. I know it's long. I want to say, how do I turn negative 5x into a positive 5x? I'm going to have to multiply by a negative 1. Multiply by a negative 1. So negative 1 times negative 5x is positive 5x. Negative 1 times negative 2 is a positive 2. Don't forget I have to subtract here. That's how we do long division. When I subtract, I end up with 11 as our remainder. We write this remainder just like we did with regular division. We write it up here in the numerator, and we write my divisor in the denominator. So I have negative 5x minus 2. But the difference between polynomial division and our other division is I need a sign right here. So since this 11 is positive, I write plus 11 over 5x minus 2. That right there is the answer to my polynomial division of this term right here. Very long and can lead to quite a few mistakes, but we just need to make sure that I think the most common mistake comes right here, where you are multiplying through with your integer signs, and then you kind of have to change your signs because you're subtracting. So let's practice this again. This time I'm going to divide x to the 4th plus 81 by x minus 3. So my x minus 3 is going to go on the outside of the house. And on the inside of the house I have x to the 4th, but I'm missing quite a few terms before I get all the way down here to the 81. I am missing a x cubed, I am missing an x squared, and I am missing an x. And because I am missing all of those terms, I have to put them in with 0 as their coefficient so they hold the place within this division problem. So that's kind of the key to this type of a problem where I'm missing some components. I just need to add them back in with a 0 as their coefficient. And now I can go through and divide like I was doing before. I think to myself, how do I turn this x into x to the 4th? Well, I need to multiply it by x cubed. Because there's 2 terms on the outside, I needed to start 2 terms in. So x cubed times x is x to the 4th. X cubed times a negative 3 is negative 3x cubed. I'm going to subtract and subtract the second term, which means it changes to plus plus. So I'm subtracting here, changing the sign, and really adding on this one. So I get 3x cubed, and I need to bring down this 0x squared. So this x turns into this 3x cubed by multiplying by a 3x squared. 3x squared times x is 3x cubed. 3x squared times negative 3 is a negative 9x squared. But remember, I have to subtract, so I really am just going through and changing both of my signs. Add straight down, I get 9x squared. I'm going to bring my 0x down. So this x turns into that 9x squared by multiplying by a 9x. 9x times x is 9x squared. 9x times a negative 3 is a negative 27x. And I'm going to remember subtract, so I change both of my signs. So now I have 27x, and I have to bring this 81 all the way down. So I think, how does x turn into 27x? But by multiplying by 27. So 27 times x is 27x. 27 times negative 3 is a negative 81. And just when you thought it was going to cancel itself out, don't forget I have to go in and change my signs. Since I did that, I can add straight down and I get 162, which is my remainder. So I'm going to take my remainder. My remainder is positive, so I put a plus sign here, write the remainder over the divisor, and there you have the answer to your polynomial division. The key to this one was I had to fill in the missing place values with 0 for coefficients in order to continue or to carry out the division. So let's practice this one more time using this next example. Here I have the polynomial 4m cubed divided by the binomial m plus 4. So let's write m plus 4 on the outside and m cubed, no, not m cubed, 4m cubed, 4m cubed plus 14m squared minus 5m plus 12. So I have two terms here, so I'm going to start two terms in when I write. And I think, how do I turn m into 4m cubed? I need to multiply by a 4 and multiply by an m squared. So 4m squared times m is 4m cubed. 4m squared times 4 is positive 16m squared. Don't forget we have to subtract, so we're really going to come in and just change our signs. Now I get 14 plus a negative 16m squared, so I have minus 2m squared. Bring my minus 5m down. So m turns into negative 2m squared by multiplying by a negative 2m. Negative 2m times m gives me negative 2m squared. Negative 2 times a positive 4 gives me negative 8m. I'm going to subtract, which means I'm really going to change my signs right here. Now I get 3m plus 12. So m turns into 3m by multiplying both terms by 3. 3 times m is 3m. 3 times 4 is 12. Don't forget to subtract, which means I'm changing my signs. So I get a remainder of 0, which does happen. So my answer is 4m squared minus 2m plus 3. The key to doing long division is it works on numbers that are binomials in the denominator. You could always do long division with a monomial, but where we changed it into, instead of changing it into fractions, we actually did long division this way, but that's too hard. We want to stick with something that's a little bit easier, and long division is tedious, but it can be done.